Alright, so we're up to question 10, which was a very, very tricky question, considering all the methods exam ones that I've had a look at. So let's get into it. So it says let f be a function that maps from R to R, so it just covers all of the reals, and the rule being f of x equals e to the negative mx plus 3x, where m is a positive rational number. So so we've got m greater than 0. So find in terms of m the x coordinate of the stationary point of the graph y equals f of x. So if we want to find a stationary point, I'd be thinking we want to find out what the derivative is, f dash x. So let's go and find that. So the derivative of e to the negative mx is just going to be, so we're doing the red part first, is just going to be negative me to the negative mx, and then the derivative of 3x is just plus 3. So clearing that up, we just get f dashed x equals negative me to negative mx plus 3. So to find the stationary point, we just set this equal to 0. So we get negative me to the negative mx equals negative 3 once we subtract 3 from both sides. So those negative terms, if you like, would cancel, and we can turn this into e to the negative mx equals 3 on m. So we're dividing through by m. So we get rid of it on the left hand side and we're left with 3 divided m on the right hand side. And then we're just going to take our equivalent log statement. So we're going to get log e of 3 on m is equal to negative mx. So the last thing is just to isolate x, is that we divide through by negative m, divide through by negative m, and we get that the x coordinate is going to be equal to negative 1 on m by the log e of 3 on m. So that's your x coordinate, and that's all we need to do for the first part of this question. Alright, so part 2 says state the values of m such that the x coordinate of the stationary point is a positive number. So we want the x coordinate to be positive. So this fooled a lot of people. So you got 56% of kids getting the first part right. So all the way down here, over half of the people got to this point, but only touch under 20% actually got this bit right, and it's just your understanding of how a log function looks. So if we were just to graph log x, so that's log e of x, all it's asking for is the value of m such that the x coordinate of this stationary point is positive. So if we want positive in the blue, this bit here, we just want this part. And that starts on your basic log graphs when we go past x equals 1. So that x is obviously the argument inside the log e expression. So from the previous slide, hopefully you recall that the x coordinate was equal to negative 1 on m of log e of, let me just get this right, 3 divided by m. So using our plug rule, we can take this negative 1 and bring it up to the top. So we can rewrite this as being x equals 1 on m log e to the 3 divided by m to the negative 1. So that's just going to flip that, isn't it? So we're going to be 1 on m times log e of m on 3. And from our little discussion over here, we want whatever's within the log, so the m on 3, to be greater than 1. So therefore, we want m is greater than 3 for a positive x coordinate. And that's your answer there. Alright, so for a particular value of m, the tangent to the graph of y equals f of x at x equals negative 6 passes through the origin. Find this value of m. So this wasn't done too badly. 22% of kids got to the answer. So we want to find m. That's what we're trying to do all the way down here. M equals something. And we want to find out what that something is. But we're going to have to use a fair bit of the information we've got previously to actually work out what this is. So we've got, for a particular value of m, the tangent to the graph. So we're dealing with the tangent. So we found f dash x was equal to negative m e to the negative mx plus 3. We had f of x being equal to e to the negative mx plus 3x. And now we can substitute in our x equals 6 case to start finding some coordinates. And we also know it passes through the origin. So if something passes through the origin, we have an xy coordinate equal to 0, 0. So we've got that point. And we've also got the coordinate of the negative 6. So if we go f of negative 6 equals, so what's that? E to the negative m by negative 6 plus 3 by negative 6 is e to the 6m, positive, because there's two negatives turned into a positive, minus 18. So therefore, our xy coordinate there is going to be, x was negative 6, y is going to be e to the 6m minus 18. So that's a coordinate, along with this one up here that we already had. And finally, f dash gives us the gradient, doesn't it? So this is a gradient function. So if we then evaluate f dash of negative 6, our gradient, it's going to be negative m e to the 6m plus 3. So now I'd say we've got two fairly important bits of information. On this side here, we've got the gradient of the tangent at x equals negative 6. And over this side, we've got coordinates that lie on that tangent. So being a little bit clever over on this side, we can say that m, the gradient, which is going to be the same as this is m, the gradient. So sort of don't confuse m up here with the actual gradient function. This is just our slope. So m, or I'll call it the slope, is equal to y2 take y1 over x2 take x1. So we know we've got all the coordinates we need. We know, so y2, x2 will let be this guy here. So y2 is just going to be e to the 6m minus 18. And then we're going to subtract away from that the y coordinate up here. So from the origin 0, then down the bottom, we're going to have our x coordinate of negative 6. And then again, we're just going to take away the x coordinate from the origin, which is 0. So we just find that this is e to the 6m minus 18 on negative 6. And that's our slope. So from here, we should be able to link this bit of information, which is a slope, with this bit of information, which is also a slope. So what we need to do now is just equate the two of them. So we're going to get negative m e to the 6m plus 3 equals e to the 6m minus 18 on negative 6. So if we times everything by negative 6, so I'll do my working by negative 6, you'll see that they cancel there, and that we're just going to be left with positive 6m e to the 6m plus 18 equals e to the 6m minus 18. So, sorry, this is going to be minus 18. Minus 6 by 3 is negative 18. So this will cancel with this, and we're just going to be left with 6m e to the 6m equals e to the 6m. So if we divide both sides by e to the 6m, so let's do that, divide by e to the 6m, divide by e to the 6m, we get this is going to become 6m equals 1, so therefore m equals a sixth, and that's the value of m that will give us a tangent at x equals negative 6 that passes through the origin. So yeah, if we complete what we wanted down the very last bit, we wanted m, and we get that to be m equals 1/6.